For this question here, let's start by talking about what a prism is. A prism will have two identical faces stretched apart like an accordion. So let's just imagine for a second that we have a rectangular prism. This is called a prism because it's got two identical faces, the rectangle at the bottom and the rectangle at the top, for example. So those two identical faces, those are what we call the bases. So we'll call those B. And the distance between them, that's the height. And so the volume of a prism is capital B times H. And this is capital for a reason, because it's the area. Just as an example, imagine you take a piece of paper and you just lay it on your desk. And then you lay another piece of paper on top of that, and another piece of paper on top of that. Very quickly, you'll have a rectangular prism. So that's the idea of the area of the base times the height. We're talking about the area of one piece of paper multiplied by the thickness of the stack of paper. So now that relates because a cylinder is kind of a prism, even though technically speaking, a prism is not a shape with rounded edges. So a cylinder is not actually a prism. But functionally it is, because it's got identical faces at the top and the bottom, and these are circles. And then we've got the height, the distance between those identical faces. And that's why the volume of a cylinder is pi r squared h, because that pi r squared, that's just the area of a circle. And we're multiplying that by the distance to the opposite circle. Now, why are we talking about prisms in a question about cones? Well, one interesting thing about pyramids and cones is that the volume of a pyramid or a cone is 1/3 of the volume of the rectangular prism or the cylinder that envelopes it. So if we draw a pyramid, a square pyramid, inside of this prism, that volume is 1/3 of the volume that we would normally have for that rectangular prism, which is length times width times height. Similarly, for the cone, which goes inside of a cylinder so perfectly, that volume would be 1/3 of the volume of the cylinder, pi r squared h. So on your formula sheet, the volume of a pyramid is 1/3 length width height, and the volume of a cone is 1/3 pi r squared h. But it's good to understand why. It's about 1/3 of this interior space. So that's like 1/3. This would be about 1/3 as well, and this would be 1/3. So here, coming to this question now, we know that the cone has a volume of 71,000 or so, and the area of the base is 5,929 pi. So if we think of this as the volume is equal to 1/3 of the area of the base times the height, we can start filling in. The entire volume is 71,148 pi, and the area of the base is given to us 5,929 pi. And this is perfectly set up for us to find out the height of it. So in order to know how to use the information they gave us in this question, we kind of have to know what a prism is, how to find the volume of a prism, and what's the relationship between a prism and the cone or pyramid structure that can lie within it. So now we're just going ahead and doing some of the algebra. We can multiply both sides by 3, and we'll get 213,444 pi equals 5,929 pi times h. We probably should have done this from the beginning, but we can divide both sides by pi to get rid of that. And now we're dividing both sides by 5,929. And you get h equals 36. So now that gives us the height of the cone, but be careful not to pick B, because there are few things in the world less tricky than the SAT. We're being asked for the slant height. So now it's going in a totally different direction. We know that we have a cone. Just trying to draw a little bit of a 3D cone here. And we just found out that the height of it, which is this piece right here, is 36. But what we're being asked for is the slant height of the cone, which is this right here. In order to find that, it would help to really know the radius, and we can get the radius. That's because we were told that the area of the base is this number. Now, the base is, of course, a circle. We're talking about this circle right here that we're seeing in 3D. And the area of a circle is pi r squared. So we've got area equals pi r squared, and that's 5,929 pi equals pi r squared. We can cancel out the pi on both sides, and the radius squared is 5,929, and we can take the square root of both sides. And that'll give us a radius of 77. So we just found out that this length right here is 77. That enables us to use the Pythagorean theorem here. So there are a lot of steps on this incredibly interesting question here. So let's do the Pythagorean. A squared plus B squared equals C squared. 36 squared plus 77 squared is C squared. 36 squared is 1,296. 77 squared we already knew was 5,929. And we can combine these two numbers here, and we get C squared is 7,225. Now we can do the square root of both sides, and we'll get C, which is the slant height, is equal to 85. And that's answer choice D on this super tricky question.